Yeah, thank you very much, and good afternoon to everyone. It's my pleasure to present our work, our research, but also our commercial work on biochar for AD optimization. I'm looking forward to questions, either directly after or by email if you like. So we'll start with myself a little bit to give others potentially time to join in a little bit later. Yes, so I'm German, as you may already taken from my accent. And I came to the UK based on a Marie Curie fellowship, and I started researching on biochar here at the Edinburgh University. And as an agricultural engineer, I already had experience in anaerobic digestion. And so this was a start basically of me and others here at the university investigating how biochar could be used in anaerobic digestion. And we had very good results in the beginning, which led to a patent and which led to the university supporting the spin-out process for our company. So let me check if I can. Oh, that's strange. Let's change to the next. Here we go. Yes, so our company, Carpogenics, is looking into biochar, which is specific use and functionality for biotechnical application. Our main product, our first product to market is creature for anaerobic digestion. Our second product in line is Biochar, a product that we are developing together with the wastewater industry for wastewater treatment to increase the removal of water pollutants. I'm not sure because I cannot see too many people now, but I'm certain that some of our team will be on the call. And at the moment we are 9 in our team. And yes, I believe that we'll grow further over the next months, probably be around 20 people after at the end of this year. A little bit confusing because my computer is starting to cause me a problem. Sorry. Yes, so what we are doing as research, as a partly research organization is that we test biochar production, so as a service, but also for ourselves, especially biochar from waste, analyze quality, functionality, including looking into and helping others to scale up their process. Then our AD component, we have facilities where we can test feedstock potential. Yeah, AD operators want to find cheaper feedstock. We're looking into microbial activity, also what additional biogas potential is locked in the digest state. And I think mostly we are mostly proud of what we have achieved so far in terms of fermenter optimization and the fully automated test reactor we have there, which we are using for mostly for consultancy projects, where companies come to us who want to optimize their nutrient supply. Feedstock I already mentioned, and at the moment we are trialing is a multi-stage AD process for an Irish operator. So this usually has some biochar in it, but it doesn't need to. So this is a combination that we are offering and using ourselves to find answers, find solutions, and find commercial opportunities. Okay. And on our more industrial related side, we are currently developing in Scotland the first biochar production site, an 800 tons per year production site. It's taking a lot of time, but it's exciting. I think it's a very exciting time for biochar, as you probably can confirm. So AD is complex. Anaerobic digestion is a complex multi-stage process. So I'm not able to dive too deep into this. I assume some of you have knowledge prior to my talk. Others may not be able to follow too much, but happy to answer questions after. Send me an email if you have specific question here. So anaerobic digestion, is obviously a microbial based process, which includes several stages where polymers get broken down to the final product that we want, methane. And at least 3 groups are included, and they all have to work together in harmony, if you like. Unfortunately, it's not easy. These are very sensitive microorganisms, which usually leads to inhibition at some point, underperformance at some point, breakdown. So every AD operator in the world, I assume, has seen failure, costly failure, so where no biogas was produced anymore, or very little was produced. So this, on the other hand, is an opportunity for additives, and obviously what I'm going to talk about is biochar. How can we use, what does biochar help? How does biochar help overcoming limitations? This is an article from an article by Zheng et al. That looked into how biochar, or in this case, activated carbon, impacts the microbial community structure. You can see that general understanding is that biochar acts as a colonization ground, where the microbes, different microbes, grow on, and then they have a chance to form very stable colonies, biofilms. And only recently it was found that biochar can also act as a conductor to allow direct interspecies electron transfer. This is rather new, but according to our own research and our own experience, very, very important part of what biochar can deliver in terms of benefits. So on the bottom of the page, you can see, if you focus a little bit on the green part of the cake here, that biochar seems to have a specific impact on the archaea. And these are the microbes that are producing the methane. So biochar, and this I think is in consistency with our results and other groups, biochar is specifically good in increasing the concentration of methane producer. So the microbes that you want, that we want to see in high abundance. Here's a summary of what we are seeing, what others are seeing in AD reactors, small scale, lab-based, but also commercial scale reactors. The interest is picking up. I'm from Germany, so I would say there's almost probably 100 AD operators who have tested biochar at some point. I can only pick a few, I think. Possible benefits. You should see a higher potential for methane production, biogas production, higher tolerance towards stress. So there's lots of stress. Operators tend to take feedstock, cheap feedstock that they can. It may not always be the highest quality that causes stress. Biochar seems to help break up foam. This is what we also see. Foaming is an issue at some point for several AD plants. It can lead to process failure. So we've seen quite desperate operators who couldn't deal with the foam anymore. So obviously, when there's a positive benefit, when there's an effect, there's also a risk for unwanted effects. Like any medication you take, it also has side effects, or can at least cause some side effects. And because biochar is an absorbent material, it will also absorb essential nutrients. So the question is there still enough of the trace elements, molybdenum, selenium, available for the microbes? If not, then you will see a rather decline in the performance. So not the uplift that you want, but a decline. Depending on what biochar, particle size, surface properties you add. It may also cause adverse effect on foaming. It can also trigger foaming. It can also settle or just float at the top of it. Yeah, wouldn't have much effect really if it wouldn't fully submerge and distribute equally inside the AD reactor. So our product, Creature, we have developed over the last 5 years and applied for patent protection, has some features that we think will make it a more risk-free. Yeah, there's something product which provides good chance of seeing a high uplift in biogas production, so large surface area. It's easy to suspend it in AD digester, so it's not going to float, it's not going to settle on the reactor bottom. We've also found a mineral composition that will accelerate the speed where microbes settle, grow, and strive on the surface. And we are also making our Creature product electrical conductive to a point where it supports direct interspecies transfer as an additional but very stable, reliable way for the microbes to exchange their electrons and achieve a higher metabolic performance. So for the operator, for the AD biogas producer, this means a higher biogas output, less foaming, increased process stability, and as a result of this, there's an option to decrease feedstock cost, because they don't need so much feedstock anymore because they have more per ton, more biogas per ton. They can change to a cheaper feedstock that would otherwise cause problems. And on the other hand, at least here in the UK, but also in Germany, I know of there's an increased price tag on digestate disposal. Yeah, it's very difficult. It's getting more and more difficult to find farmers who want to take the digestate. So this will also decrease costs there. So yes, we are trialing. We have done 2 successful trials. We are doing a 3rd trial at the moment, and we have 2 other trials coming up over the next months. We have tried all different areas of anaerobic digestion, the farm-based ED plants, food waste, and also wastewater. Because of commercial requirements, we have focused so far our full-scale trials on farm and food. And what we found is, maybe not such a surprise, that the benefit that our product can give, and I suppose it also extends to biochar in general, is based on the base level performance of the AD biogas reactor. Yeah? So it's very stable. If it's performing very well, then the uplift biochar can give is lower, compared to a highly stressed AD reactor. I think that is what had to be expected. So this is from a full-scale trial that we did a year ago, 2 years ago actually, in an AD reactor that was stressed. An indication of a stressed reactor is usually seen in concentration of specific organic acids, propionic acid and acetic acid. And this concentration here is very high, 1,500 or 2,500 milligram per liter. Then we added Creature, our product, just one time, and we saw a steep decline in this volatile fatty acids. Yeah, these acids are not just an indicator, but also cause for inhibition. Yeah, so you don't want to see such high levels. If you see such high level as a biogas producer, then you want to be very careful and ideally find a way to reduce it. Yeah, changing operations or what we now offer is a biochar product to get to more stable and more productive stabilities. So this was a short, let's say, emergency recovery trial. This now shows a trial that we did last year, a long-term trial where we tested it with the AD operator, how our product would help increase outputs if it would be edited daily for 4 months. This is colored in blue, so before and after. We only had one, the AD operator had only one tank really, so we couldn't do any parallel trial, but we compared before and after, and you can see that during the trial, or at least a couple of days, a few weeks after, there was a decrease in, here it's acetic acid, which means a higher uptake, a higher level of degradation into biogas. So this is what the client wanted to see and was very happy with this result. This shows the yield, the methane yield per kilogram of volatile solids. This is a very well-established parameter to understand the performance of a biogas reactor. The red line I've put in here is the long-term average methane yield, which for this AD operator was about 250. You can see it's going up and down. It's going up and down. It's also partly related to how much is fed into the reactor. This is what you always see when you're working with anaerobic digestion operators. It's never 100% stable. This is why we need this long-term trials. Just a week or a month wouldn't be long enough. So we went for 4 months. However, for us, it was good to see an uplift. So we had basically an uplift throughout the trial. On average, I think it's 20% uplift. And we even saw kind of a lasting effect because it takes some time for our product, feature or biochar in general, to wash out of the AD reactor. Usually the feedstock that is fed into a reactor stays there for 50 days, maybe even 100 days. And this equals the time the biochar will stay in the reactor. So it takes some time for it to wash out again. Last but not least, in terms of these trials, we were also able to give evidence or proof on compliance with fertilizer, digestate fertilizer land use regulations. I'm not sure about other parts of the world, but I assume there will be some type of regulations. So making sure that what you add to the land as a digestate doesn't come with a high level of contamination, specifically heavy metals. So this is this part of our investigation shows that our creature product wouldn't have any effect on the compliance with fertilizer land use requirements. So it could go directly to land. There's no need for any worries about this. Okay, so for our clients and everyone who considers using creature or biochar in general, obviously they want to have a cost benefit. This is here in comparison between standard, so biogas production for gas to grid use, and with our product based on a proposal of 15% uplift, which means 50% cost reduction. So as I said, you can reduce the feedstock cost, less feedstock, cheaper feedstock, but you will also have less trouble controlling the ED process. So that is another benefit, and so it will bring down the overall costs of producing biogas and commercializing the biogas. So let me summarize. So I think there's confirmation agreement in the academic world, but also in the industrial side of biochar and anaerobic digestion, that biochar can bring several benefits to anaerobic digestion. It may differ among the industry what type of benefit really is important. In this case, it can definitely strengthen the microflora. It can increase the concentration of methane producers. It will help to form very stable biofilms, which allow higher overall degradation rate and a more complete degradation of the initial polymers, especially fats and proteins, will be broken down quicker. This is what we understand from our results. And the risk, make no mistake, I think I already mentioned that every AD operator from time to time suffers breakdown of their process. And so far, we haven't seen any of this, even not even a slight change that would indicate trouble. So I've been adding our products, so and I assume that will also be true for other types of biochar. It will definitely help to minimize the risk of process failure, which is a big cost factor, yeah, in anaerobic digestion. So last but not least, as I already said, where there is a positive effect, there's likely also be a risk for side effects, negative effects, especially at the beginning. Yeah, you will see a change in microbial community structure, so we definitely recommend biochar trials in anaerobic digestion to be monitored, to be controlled to some point. Yeah, you may want to change temperature. You may want to change the feeding dosage of trace elements. Yeah, so this is something that has to be taken in consideration when doing a biochar trial in anaerobic digestion. Yes, so please, if you happen to be in at the Bio 360 Expo, yeah, please find us. We don't have any stands there, but two of our team will be there end of March in Nantes, in France. Yeah, so if you cannot make it, please get in contact, website or LinkedIn, or send me an email. So yes, no, I'm looking forward to your question, and I hope there was something interesting for you in my presentation. Thank you very much.
Thank you, Jan. Thanks for the presentation. Really interesting how far you have come since the start. And you got a couple of questions already in the chat. So, and also one live. So I will just start with the first one in the chat. So the first one was from Heberling. So how do you influence the electrical conductivity in your char?
Yes, so the most simplistic way to do it is to use a higher pyrolysis temperature. Yeah, the higher the pyrolysis temperature, the more graphitic the carbon will become. Yeah, so it starts becoming electrically conductive around 520, 530 degrees pyrolysis temperature, but it will get more and more electrically conductive, yeah, at higher temperatures. So this is really the key. Plus, obviously, choosing a feedstock with a high carbon concentration to begin with. Yeah. If you want to bring it to the maximum level, then you can also put some electric conductive metals in there. But I think this is something that is more relevant for specific electrical application, not for anaerobic digestion. Hope that answers your question.
We will see. There's a question from Fu Hardison. So can you unmute yourself? Sorry.
Yeah. Thanks very much, Ian, for the wonderful presentation. Actually, I have a question regarding your composition of the feedstock, because most research has shown that also carried out an experiment regarding using biochar also in anaerobic digestion, but found out that most of the time when you have a feedstock composition which is more than 3 or different, like there's a problem because more feedstocks you use, there's a high possibility to produce more volatile fatty acids. So we use biochar in setting our systems, which you know you use just two feedstocks, for instance, animal manure and maize silage, and the result was nothing. There was not actually so much there, so it was still the same. But so I want to know how many feedstocks did you use there? That's the first question. And then the second question is, biochar absorbs a lot of trace elements. This trace element is one of the big problems which anaerobic digestion systems are having, which they use quite a lot of additives. So how do you do to control the situation if you use biochar that absorbs these trace elements which are not available for microorganisms to carry activities?
Sorry, I'm afraid I couldn't really get the whole of your question. Maybe it's my computer not really working for me today. Christian, can you?
Not that was exactly the situation for me. So I just got parts of the question. Can you maybe just write your simplified question in the chat, and we will try to answer it there. I think that will make it faster for us, and probably answer the correct question in the end.
You can also send me an email, Fu. This is easier. You had a very long question. I'm happy to follow up with you after the call if you like, or send me an email. I will follow up in writing.
There was a question from Albert Bates. Is there a source document for microorganisms used to colonize biochar for anaerobic digestion?
If there's a research paper, is this a question? Or
yeah, I guess if you know a source, any source, I guess, anything written down.
Yeah, there's plenty. At least 100 peer-reviewed journal articles, I would say, have been published on this very specific area. Yeah, so just Google it, and you will find lots of research on this. Yeah, not always in line. Yeah, so some say it's only the methane bacteria that benefit. Others say there's also the fermentative bacteria that make a difference there. But yeah, this is it's always to be expected. Yeah, but no, there's definitely plenty of research published.
The next question, so we take three more questions, and then we will go to the next presentation. So Gudni was asking, what tests have you done to compare the performance of Creature compared to other biochars, activated carbons, or other conductive materials?
Yeah, in the beginning of our company, we have tested this in the lab only. Yeah, you can imagine at full scale, where they only have one tank. Hardly possible. Yeah, and I think in this way we were able to reduce some of the risks. Yeah, activated carbon. We used activated carbon as a reference material, which in layman terms stole plenty of nutrients that then wasn't available anymore for the microbes. So the process underperformed, caused trouble. And yes, we also use some standard biochar, but there is nothing really like standard biochar. Yeah, there are so many different ways you can materials, feedstocks you can produce biochar from, and then you can mill it down, grind it down to different particle sizes, and the dosage is an endless. So if you go into research, I think this has been now published by more than 1,000 authors, 1,000 papers. So maybe some of you would be interested in writing a review article on this. Yeah, please do. I'd really like to see a review paper on this.
And then you got a couple of questions about your production conditions for your Creature. I guess you cannot say everything. Any general comments on that?
As you can take from our website, we are using waste predominantly, paper waste, cardboard waste, paper sludge, which is good for us. And this is where, which we have secured as a patent, including some other aspects to it. So I think this is what I can say. But if you are interested in working with us, please send me an email, and happy to discuss opportunities. At the moment, we are planning our own production unit. At the moment, we are using capacities elsewhere. Also, we have a producer in Norway, a producer in Ireland. If you like to yeah, wherever you sit, wherever you are, if this is of interest for you, please find me, send me an email.
Okay, and the last question from Hanu. So what percentage of biochar did you put in the process compared to the feeding rate?
AD, yeah. Yeah, surprisingly little. But I think we're also proud that our product has a higher efficiency than standard biochar. So again, yeah, something that I need to keep a little bit a trade secret. We're currently going for our seed A investment round, and so I I cannot give too much information at this point. It's very for us, our company, important point. But if you send me an email and specify your question, and I'll probably be able to give you some more information on this.
Okay, great. Thank you very much, Jan. If anyone has a detailed question to Jan, you can write him an email. So you, I guess the easiest way is going over the website to contact you.
Yeah, just use the message box on the website. I will monitor the incoming emails over the next days, if you like. Yeah, please. That is probably the easiest way.
Okay, great. So thank